Woo! All right, all right. Welcome back, people. Hope everything's good. Hey, if you're not subscribed, please subscribe. I'd love that. Give me a big thumbs up. Throw me a comment if you like what I do. If you have a little critique as well, whatever you got, throw it at me. Okay, this is linear functions individual practice test for some of us who are going to test on this material. So if you want to, you can download this in Spanish or in English and go ahead and perform it and come on back. Okay, this is an equation in slope intercept form. Y equals mx plus b. There's your slope, and there is your y-intercept. All right, so y equals mx plus b. Okay, so notice they asked me to identify my slope. That is my rate of change. The rate of change is always in front of your independent variable or your input variable, which is x. The y-intercept is right there. So if I let x equals 0, this goes away, and I'm left with that. That ordered pair is on the y-axis. So we call it the y-intercept. To graph it, you go ahead and plot that y-intercept right there, and then you do rise over run, down 1 over 4. And now you just draw your line. It's a solid line because it's just a generic graph, so all fractional decimal inputs are valid. That is the end of that line. Let's go. Okay, this equation is in what we call standard form. Standard form is ax plus by equals c. To find the x-intercept, you're going to let y equal 0. Always. When I say find the x-intercept, let y be 0. That means this goes away. Divide 6 by -3. You get -2. Now they're going to say calculate the y-intercept. Well, calculating the y-intercept means x is 0. Notice the number in front of y is a 1 because it's 1y. 6 divided by 1 is 6. I'm going to plot those 2 points. -2, 0, 0, 6. I'm going to draw a line between them, and that's it. We're done. Every ordered pair that lands on those lines is a valid solution. And so we show the graph because the graph represents the solution set. Okay, let's keep going. This is fun. We're going to graph this line, x equals -5. This is what we call a vertical line. So you go where x is -5, right there, and then you draw a vertical line. Because every ordered pair on the vertical or above and below that point, x always equals -5. The y value is changing, but the x is consistently -5 everywhere on that line. Okay? All right, now I'm going to go ahead and graph y equals 0. To graph y equals 0, I'm going to go where the y value is 0. Well, this is a tricky one because the y value is 0 right there. Okay? Now, this is a horizontal line. So y equals 0 gives me this. Bada bing, bada boom. All right, that's it. Those are the graphs. The point of intersection is the point right there. And that point is -5, 0. -5, 0, right there. All right, here's the next one. On Quan's farm, there's a storage tank. The tank holds 5,400 gallons of water. Okay, that's the initial amount of water. So 5,400 is the initial amount. Quan is on vacation, then takes sprang a leak. Oh no, Quan. The average rate of flow that leaks water out is 7 gallons per minute. We're going to create a function, g of m, where m is the input value and g of m is the output. All right, the initial amount is, I think I said 5,400. That looks like 5,600 to me now. 5,600 gallons. The flow rate is 7 gallons per minute. Let's write a function. So the output variable is gallons, g of m, gallons left after so many minutes. Notice the amount of water in the tank is decreasing. So our rate is -7, right? It's a negative rate. because we're decreasing from the initial amount, times the number of minutes that the leak has been happening, plus the initial amount. Right there. Okay, let's create a table of values. Well, I know that I want 0 minutes to be my first value. That's before the leak sprang. And now what I need is I need to show gallons left at 0, because I know after when the tank reaches 0 gallons, however many minutes that took, it's not going to leak anymore because there's no water left in it. So how do I figure that out? Well, I just take the amount of gallons in the tank and divide it by the number of gallons that leaks every minute. And that'll tell me the number of minutes. So I'm going to do 5,600 divided by 7. That's 800 minutes. Okay, they asked me to make a table with 5 inputs and outputs. So I'm going to do 200, 400, and 600. You like a good span between the minimum and maximum minutes. Now I'm going to go here, and I'm just going to input those in one at a time. So -7 times 200. I'm putting it in for minutes, right? That's what we're talking about. And I want to know how many gallons. 4,200. I'm going to do it again. That's 2,800 gallons. I'm going to do it again. That's 1,400 gallons. All right. That's the end of that. Now let's graph it. The horizontal axis is gallons. Sorry, minutes. The first column is always the horizontal axis. I got to go from 0 to 800, so I'm going to do increments of 50. The gallons, I got to go from 0 to 5,600, so I'm going to do 500. 0, 51, 52, 253, 354, 450, 455, 556, 657, 758. And now I'm going to go here to my galones, and I'm going to go 0, 5, 1,000, 1,500, 2,000, 3, 4,000, 6,000, and 8,000. Okay, that's a nice span. That's a really good use of my coordinate plane. All right, let's plot our minimum and maximum point for minutes. 0 minutes, 5,600 gallons. So, I went way too high. So 4, 5, 55 is a little bit above 55. So that's right about there. And then I'm going to do 800. 0 right there. This is continuous, right? I didn't even answer that question before I graphed it. Time leaking water, it's continuously leaking at that rate, right? It's not big chunks. It's not a chunk at a time. So that's how I know it's continuous. So continuously leaking. Leaking since fractions of minutes are valid. Okay. Identify the minimum maximum output value. Well, the minimum and maximum output value is the gallons of water. So 0 is the minimum, and 5,600 is the maximum. How much water is left in the tank after 6 hours? Okay, we got to convert that to minutes. So there's 60 minutes in an hour. So that's 3,600. Go to your calculator here and do -7 times the number of minutes that you want to find out how many gallons are left plus the initial amount. Woo! That's crazy. That's crazy. Way too many. I typed in 3,600 by accident. 2,880 gallons. Make sure you use unit of measurement here, please. All right, how many minutes did it take for the tank to have a total of 3,899 gallons? Okay, well, that's my output value. So here's my function. I'm going to let my output be 38.99. Subtract 5,600 from both sides. That gives me negative 1701. Now divide both sides by negative 7. And it took 243 minutes. All right, good job, everybody. Okay, let's keep going.